Austin is making up this adapter here. It's for the NT50 onto this chuck, and the next thing he's going to do is he's going to measure his counterbore here, and he's going to machine a little step in this that will then fit inside of the chuck. So that'll be his next step, and then he'll go ahead and thread these for not 12 millimeter by 1.75 like the chuck came with, because we had half 13 socket head cap screws, which will be perfect.
I don't know if you'll be able to pick up the audio right now, but I had to weld up this area here all the way around here so it's a little bit tighter so I can make the step. Wow, so pretty.
This is a barrel that houses bronze bushings. Their bronze goes in here, and then keyways and other bronze guides. This is originally for positioning part of the boom assembly for a Atlas Copco bolter. And we used to make the inside pieces for these, and we also rebuilt the insides of them when they would get worn out. If you look on our site, you look a little bit, you'll see a little short clip of our shaper cutting new keyways in these after this keyway that gets worn out. Anyway, we're going to use part of this as part of our guide system for working with this rotor for rebuilding it, since we no longer rebuild these. Nobody's wanting them these days, and this is just scrap metal at this point. So on this piece here, we have our 3 guide pads, which are adjustable. We didn't want to wait for it to wear in to the proper curve on the piece that it's being guided on. So we adjusted those to a middle of the movement, and then we started boring them out. However, boring those out with 3 different places makes it really hard to measure what diameter you're setting them to. So what we did was we bolted on the opposite side over here. You have to look inside of this. On the opposite side, we bolted another piece of bronze so that we could have a direct measurement across the 2 with an inside mic to get the diameter. And then when I pull this out of here to attach the cutting tool to it, I will also just pull those screws out and be done with the measuring pad, because we don't really need it in there for anything else. So we had 15 thousandths and 7.5 inches. We're at 32 inches from our pivot bar there. So we're going 64 thousandths to get closer to straight. And this is one of those where we need to swap 2 earplugs and a reel tapper. Give me the 20 pounder. I have earplugs, I think. Now if this was something that we couldn't hit on with a hammer, then we would have to do something else, like set up a jack, and we may eventually have to set up a jack anyway. I just like to keep it simpler if we can. Smaller taps, we're close. Only got 1/1000th to go. There's it, 64. We're showing off by 2. Still positive. Let me see if it repeats to the 0. Yep. Okay, so we're 2 positive. So our 2 thousandths divided by 7.5.
8.5 thousandths.
Okay. I figured it would be close to 10, because when I look back at my clock here, I actually went exactly 54 last time instead of 64.
Oh, convenient.
Okay, that's 8.5. It actually was 8.5. Landed on half real easy that time.
Well, that's convenient.
We're getting set up to put our tool in here so that we can turn stuff. We have top secret innovation that is used by machinists everywhere that do a lot of field type machine work. Piece of banding. But explaining what we got going on here, we have our custom turning fixture that we built, essentially a steady rest here. I put the indicator on it to see how much deflection we were getting out here between the quill and the pads, and we're essentially getting 0. Up to 1,000ths didn't bother me, but we're getting 0, so that's close enough to no movement. If I barred it, and there might be some more, but we're pretty much there. So this is our steady rest. We've got our chuck that we dialed in here. We thought about this a million years, and dialing in what we dial in is not really important because our cutter's going to go on the end. We got a chuck here. Whatever axis this tube turns on is not that important. We just want it sort of towards the middle of the tube. Our cutter here, what I was just talking about a minute ago, is a piece of band stock. You put that in here so that your set screws don't put divots in your tool and make it hard to move. And what you can do is you can actually just slightly tighten this, just like a weigh on a machine, and you can put an indicator so you see how far to travel, and you can turn your pushing screw, which in this case we selected a 1/2 20, so this will actually be 50,000ths per turn. So it's also, for the rough cuts, pretty identifiable. It feels like the shim stock is slightly wider than our bracket, and it is, so I am going to send Austin to go sand that widthwise, on the sander, about take us 10-20 thousandths. I'd rather have it loose. Just about even. We have a piece inside here. You can see part of it through the hole. There's a piece inside there that is lined up with the first part of the shaft, which is still good. Now, a part, of course, that's still good also, put a little more whey oil on here. Part that's still good that we had to straighten it and get it in line. That's probably on a different video reel. And we're about to put this together, and
Is this right?
yes, put this together and start doing our first test cut this evening. So that goes on. Okay, this is going to go up against the plate so that it actually captures the tool. So no matter what, it's there. So we have gotten through all of the weld, and we were starting to have a little bit of chatter on the last cut, and I've taken over from Austin because it's not fair for to have him responsible for this. Plus, for the customer. It's one of those things, you have your guy with the most experience doing it. You just do. I went ahead and readjusted the 3 points here on our steady bearing, and so I tightened that up a little bit after loosening them first to float that in. I can see that we're slightly out of round the way that this runs in relation to the world, this tube and everything. The only things that really matter is where it's running around here and where it's running in relation to the bearing at the other end. The rest of this can run however wonky it is, but if I built a similar thing again, just for peace of mind and ease of doing things as we built it, I'd make some extra round places on it to dial in on instead of leaving it so rough. Because you can definitely see it. And we could have adjusted it so that it's tighter and cocked it in the chuck, but it's cutting good right now. Fact is, this right here from one end to the other is within 0.5 thousandths of being the same size. We were within 1.5 before when it was chattering. The other thing I did was I changed our insert radius. I went from a 3/64 radius to a 1/64 radius. The end down here, when we finish, is supposed to be an 1/8 inch radius.
which will be done with a different cutter altogether. And I didn't want to try and have a large, so if you see down here, if you have to come around with that camera, at the end, I'm just making a square here where that radius goes. So I just turn up to it and then we'll put that radius in last. There's a little bit of, the surface is fairly rough. This machine only goes down to 10 thousandths inch per revolution. So that leaves it a little bit pointed, and we'll leave a little extra material to polish when we're all done. Knowing that we're going to polish off a couple thousandths right away for that surface finish. We're going to shoot for a little bit over. We're also going to shoot for a little bit over. I'll end up shooting for about 5 thousandths over and consider that done. Well, that's a little extra time polishing in at the end. It's a lot to get to this point again. The customer doesn't need to wait on us in case it goes under. And as accurate as things seem to be going, things can go wrong at the last cut. And it's just not worth the gamble. So we're going to shoot for a little larger and polish it in instead of taking the gamble of having a problem. These bearings here seem to be holding up pretty good. We used aluminum bronze on it. Usually use a softer that wears in better, but we used aluminum bronze. And there are some chips that are tracking back and getting in there. I see them pushed away though as I leave oil here. I'm putting lots of whey oil on that, and I put some in as I first start, but then as it rotates it slings a lot off, and I just keep looking to make sure that there's some on the actual guide shaft inside. We could have, had we addressed it early on, we could have made a nice little wheel here with numbers, and this is 50 thousandths movement per revolution because it's a half 20. It's 20 threads per inch. But, which is just twice as coarse or half as many threads per inch as a micrometer. Micrometer will normally be 25 thousandths per revolution. And we could have put a dial on there. I've done that before, and you can come up pretty good with just a dial, but it's something more to build. Easier way for what we're doing right now, I just put a indicator on here, and I see as I touch it and moving things, it moved off of the half thousandths slightly. My previous cut was 10 thousandths per side, and I'm going to try and go for 20 thousandths per side because we've, on this next one, I'm not going to get too brave because just because I reduced, eliminated actually the chatter that was in here doesn't mean that we need to gamble too much. But I've got roughly 80, I'm at 95, 595 right now. We're going to 512, so I've got about 80 thousandths total that we're going to be taking off. If I come in by 20, that'll give me 40 on the diameter, and will get me closer without being too greedy. You notice that there's some shiny lines and not shiny lines in through this material too. That's part of being welded. We've got our rod, we've got whatever the shaft was originally, which nobody knows. You've got another thing that happens here is we're getting some carryover. Basically, we're machining this dry, but we get some carryover oil. So as the oil spots come in, they will change the cut a little bit. The size is coming out good, but it's got some changes in the consistency of the metal. Is there anything else that I was wanting to mention? Oh, just that when I return with this, we have a mark I had made on the dial here because it's a longer cut than what the dial is calibrated for, so I can't really set the dial in a place, but it will come back to the same. And in fact, that is wrong. That was part of, I need to carry that through because this dial doesn't actually lock to this. I was wanting to make that silver that was just right. Yeah, it comes up there onto the machine because this dial floats. So yeah, my mark that I had made across the dial, if I lock it, then it kicks out the feed. So I don't want it kicking out the feed. I want it to be consistent all the way through. We could hand feed it, and we even talked about, I'd still like to, one of these days I'd like to put a pulley on here along with the hand wheel, add a pulley, little V-belt, variable speed drive so that we can slow it down further. You can, for short distances, run it by hand. I've done things like this where I've ran them by hand the whole distance, and we could. I don't want to. We don't have to. not gonna. That's part of getting, more years on this stuff. There are ways. I did one where just for a quick drive, well, when we were doing the 994 on it, it was the back of this mill right here, in fact, is what it was for our feed, was that part right there where the socket is on. And we put a 16-to-1 torque multiplier on that. And then we had it set up where we could drive it with a drill motor. And we had variable speed drill motors, so that made it. And I talked about making a nice drive unit for that with a quality variable speed motor and stuff, but we just, you can only build so much of this stuff not knowing what you need next time. So, I'm gonna try and leave a little bit of snug on one screw, which we set first before we loosen the others, since you can feel it better while it's being held down, how much is snug. Then I loosen the other two, and we will come in here by 10 and 20. Sand that a little bit, polish it all a little bit. We're 3/1000ths over ideal right now, which is good because there's a little bit of little peaks to the surface there. So I'll polish it down real nice. And to start with, what I'm going to have you do, Bert, is I'm going to grind a little bit. And when I quit grinding, you don't even have to be here where you're in the grinding sparks.
Yep.
Turn it forward about a 1/16 of an inch, about a 1/16 of a turn. No. Yeah. So I'll grind a section and then you turn it, and we'll just keep doing that. And then we'll go to the next stage. Okay. Yep, I do want a face shield. You been around?
I think so, yeah.
Okay. Yeah, you want to, let's see. I'm on this side. Yeah, pull it up. Actually up, yeah. Yeah, go ahead and let it move. Oh, I'm gonna try the other air first on that. I'm gonna just
Clear the top out.
We don't know which is going to work the best for that. I know what I'd like to have, but I don't have that today. I'd like to have a 1/4 inch diameter abrasive bit. Okay. Go ahead, turn it. Just keep it turning up.
Faster?
Yeah, speed. Motor on.
This way?
Yep. Okay, you want to give me a 1/8 of a turn?
Yeah.
Either direction, I want to go in 8 different places for measuring. won't make that too pretty, I guess, there. It's okay. It's okay. Don't feel any bad burrs, nothing there. I would say that that's it.
Wow. Really?
That's it. One little job done. One little job that took 7 weeks. But we had, lots of in-between building, thinking. We didn't work on it 100% of the time, all that time. No, we probably put in 15 to 20 hours a week, realistically. I'll go see on the billing what we got. It wasn't 40 hours a week working on it.